Okay, so today we're gonna be looking at the calculus. So for a calculus, one of the things that you have to understand is you have to understand what is the limit. Yabo. So the word limit, we usually hear it. I don't know if to segue when it comes to e card, yabo. Whenever like you're using a bank card and then they say you have a limit, what does that mean? That means that is like the amount that you cannot exceed. Yabo. So if you like your limit is 5,000, so that means you can't spend more than 5,000 in your card. Yeah, so it's the same thing ngala futhi with calculus. Calculus, we're gonna be looking at some graphs. Yeah, we're gonna be looking at some graphs and go on some graphs. When we're talking about the limits, we are talking about where the graph cannot end. Cannot pass through. So it will be more like going towards that value. If you remember asymptotes, you remember when you're talking about asymptotes, asymptotes, they are more like a limit, because that is where the graph cannot pass. That is where the graph will go towards. So they will be going towards a certain value. So yeah, that's like the understanding of a limit. So yeah, it's more like as I stated, it is or let me just say it's the maximum value. It's the maximum value. Yeah. So whenever you're looking at ilokunjana for graphs, how do we actually do it when it comes to graph? Usually you'll be given the limits of x. You have to determine ega y. So yeah. So for an example here, they said that we must determine the following limits. So as I stated, the limits of works for every graph. The graph that we are given lana is 2x squared plus bunny plus 4. So la the limit they said is x is 1. So that means where you see x, you will put bunny, you will put y. So determine the limits, the y limit. So that is gonna be 2, and then when you see x, you're gonna put bunny y 1, and then carry on all squared plus 4. So that means la limit actually was uba, so 2 times 1, that is more like 6. So this was gonna be your answer. Simple, yabo. And then this side, for this side to be, let's look at to be in a corner. Same thing, where there is x. So they say that the limit is x is 2. So where there is x, we'll put 2. So that means here we have 2 all squared minus 4 all over x. The x lana is gonna be 2 plus 1. But unfortunately, now 2 squared is 4, so 4 minus 4 is 0. So 0 divided by 3, that is gonna be 0. So the graph will be going towards 0. So just think of it like a asymptote or something like that. Okay, here's an interesting one. If you look at this one, there's something that I want you to notice, like that I'm gonna do purposefully so that you can notice. Okay, so here we'll be doing what I just told you. What are you gonna be doing? You're gonna be, so they say that the limit is x is 1. But if you put 1 here on top and then you put 1 here, now I don't know if you can notice the denominator will become 0. Remember, whenever the denominator is equal to 0, your answer will be undefined. So here we don't want it to be like that. The reason there is a possible answer here, but then what must we do to get the answer that we desire? Because now we can see that whenever you put 1 in the x, it will just automatically in the denominator it will be 0 and then it will be undefined. So what are you gonna do? In these cases, the first thing that you must think of is that you must factorize. So it's one of the most important skills here in calculus. you have to know how to factorize, yabo. So you have to know how to factorize all the different types of factorizing. When I say the different types of factorizing, it's a common factor. Know how to take out a common factor. Remember, you take out a common factor if you have two terms, and also the quadratic, factorizing a quadratic, quadratic term, maybe like if they're like three terms above. So yeah, so let's continue with that. So here, how are you going to factorize it? So here, because this is x squared minus 1, this is a difference of two squares, yeah, above. So a difference of two squares, how do you approach a difference? So x squared minus 1, it's x minus 1 all and x plus 1. So I factorized that one on top, and then x minus 1. So can you see all of a sudden there are two brackets cancelling each other, né? So you are left with what now? You are left with x plus 1. Now you can use the limits. So whereby where there is x, you're gonna put what? You're gonna put plus 1. So here's another thing that I want to tell you. If you haven't put the limits of x because is 1, you are still gonna write here lim and then x is 1 because you haven't put it in the x. But when you place it when you say 1, you can now no longer use the lim x is 1. So the answer here is 2. Yeah, so let's move on. So this was just the background, and we have to know this. Must would say for the average gradient, whenever you're talking about a gradient, you're gonna see as you continue, when they say average gradient, we're also gonna be talking about something like it's more like a rate of change. You see, it's a rate of change. We're gonna go deep in that whenever we're doing about must send ama rates. Yeah, we're gonna talk more about some lentos and rates of change. But here we're looking at average gradient. The word gradient, don't be startled by your average. The word gradient, what is it telling you? Okay, gradient. Oh, how do I calculate gradient? From grade 9, from grade 8, we're calculating the same way. Gradient, what do we say? We have 2 points, 1 and 2, and then you're gonna say change in y over change in x. y2 minus y1 over x. So you start with x on y on top, and then x be on the denominators. So I want you to notice something here in this example that I just did here, or in this diagram that I just did here. Here we have x, so here we have a graph of f. This graph is called f, and in this graph, let me just use this color. In this graph of f, we have a point 1. Here's a point of 1. So we have x, and then we're gonna have x plus h. Why did I say x plus h? Because now it's more like we have shifted the position of 1. So we have shifted the position because we went this way. We said x plus h. So we said plus h. We don't know how many units, but we know that we're gonna be saying x plus h. You see. So these are the coordinates for the x values for the 1 and 2, but we want the y values. Remember, when it comes to y values, here for x, we can just say it's gonna be f at x. You see, the f and then the x. So this is a y value. Here for the x plus h, what can I say? I can just say f and then x plus h. Here it's the y value nakon. So in order for us to determine the gradient, what must we do? y2 minus y1 over x2 minus x. So can you see now what we're going to do? Instead of writing it here like this, now we're going to say the gradient now, the average gradient. Listen. The average gradient, it's going to be ubani, it's going to be fx plus h, which is the y, minus f at x all over what? what did we say? We have the x values, so we have the one that is gonna be x plus h minus the one that is h. Minus the one that is gonna be x, not h, minus ubani x. So that means at the end you have something that is gonna say, because now the x's will cancel each other, these x's will cancel. So at the end you're gonna have something that say fx plus h is to f at x and then all over h. Now this is called now I'm introducing you to something new. I'm introducing you to something new here. I'm introducing you to something called the first principle. You see, this is called the first principle. Here, what we're talking about here, it's called the first. If you had any trouble with understanding, rewind the video. So here I'm introducing you to the first principle. The first principle with the limits of h, always, limits of h is so 0, always. We have fx plus h minus fx all over h. So here we are also determining the average gradient, but we are determining the average gradient using a formula that is standard, which is called the first principle. So we are determining the average gradient using a standard formula, which is going to be the first principle. So determining the average gradient. So this thing is so easy, it's so easy. The first principle, it's one of the marks that you're gonna collect in your exam, because the thing that you're only doing here is you're just using the formula to your advantage, because you have the formula. When they say first principle, the thing that comes to your mind is this formula. We are always gonna get it in your exam. So number one, let me show how you use it. The first principle. They say find from the first principle the gradient of f at x equals to negative 3x plus 5 at any point. Now listen very carefully. How do you do it? I'm sure you noticed that we have the fx, but the one thing that we do not have, we do not have the fx plus h. So how are you gonna do it? So now let me write it, the answers with a different color. So now you're gonna say, because now we do not have the fx plus h, remember the formula requires what? Fx plus h minus fx. We do have the fx here, we are given as part of the question. The fx is present. What is the fx is equals to negative 3x plus 5, but we do not have fx plus h, so we have to find it. So when finding it's fx plus h, so where there is x, we will add an h. So that means negative 3 and then brackets x, and then where there is x, we add an h, so plus h and then plus 5. That's it. You see, now just solve here. When you solve, you're gonna get negative 3x minus 3h plus 5. You see, so now if you go to your, let me insert here. So if you go to your formula that you are doing for the first principle, now you can determine the first principle. So what are you gonna say for your first principle? You are gonna say fx plus h minus fx all over h. Don't forget to write lim h is to limiting h is so 0. Now what are you gonna say? So limits is so h is so 0, and then putting the fx plus h formula, the one that you just this part, we're gonna put the formula that you just wrote down. So you're gonna do what? You're gonna say negative 3x minus 3h plus 5. You see, that's the fx plus h minus brackets. I'm putting in the fx now, which is gonna be negative 3x plus 5 all over h. You see, so let's go and try to factorize and do everything right. So lim, remember what did I say? If you haven't used the 0 on the h, you can't remove the limiting. H is 0. You have to put it there up until you use the 0. So let's continue and solve for the numerator. So you're gonna put about lentozano negative there, and then you're gonna get something that is gonna be negative 3x minus 3h plus 5 plus 3x minus 5 here on top, and then h. So let's go and look for like terms. So the like terms, things that are going to be cancelling each other, negative 3x and positive 3x, and then the 5 and the 5 will be cancelling each other. And what are we left with now? We are left with something that is going to be limit h is to 0, and then it's going to be negative 3h all over h. You see, so in this case, what happens? In this case, you see that the h will cancel the h. You see, if the h cancels the h, now there's no use of us keeping the limit h is to 0, because now we can see what's that means here in this case the limits will be negative 3, and we do not have to use the h. The answer we just got it. The limit is going to be negative 3. You see? Yeah. So it was kind of easy. The limit is going to be negative 3. Remember, in the denominator, there must not be a 0, né? Otherwise, it's going to be what? It's going to be undefined. Okay, let's continue okay, now. Let's see. Okay. Sorry. Right. So number two. Now we're gonna be saying determine f from the first principle. Yeah. So another thing that you must know here that I forgot to emphasize. It's very important. Under equal sign here, we're gonna be writing f prime x. This f prime. This is what I'm going to be writing. Yeah, well, whenever I write this, just know that this has been derived. I'm still going to explain this word as we continue with calculus. What do we mean by derived? But this has been derived, you see, or we've been able to determine the average gradient. You see, yeah. Let me just put like that. We have been able to determine the average gradient. So here, this also means when they say determine f prime, so here they mean that we also have to determine the average gradient. You know? So it's a matter of a gradient. We're still determining the average gradient using the first principle. Okay. It's the average. So from the first principle, so it's the same thing. Remember the formula for the first principle, it requires you to determine, here you only have f at x, but it will require you to determine fx plus h also. So you have to say one where there is an x, you're gonna add the h, but here there's an x squared. Remember I said we must add the h on the x, so you're gonna put a bracket and then x. Remember the squared can be put outside, so x plus h and then all squared, ne? So the squared is gonna be outside, you see. So in our local we're gonna say 1 minus and then 3 and then deal with the brackets, board mess. It's gonna be x squared plus 2xh plus h squared. So I just skip the steps of creating two brackets, but when you create two brackets you're gonna get that answer. So and then multiply. So you're gonna get 1 minus 3x squared minus 6xh minus 3h squared. So this is your fx plus h. So when you go and do your when you're deriving now, or when you're determining your first principle, you're gonna say f will equals to limits h is to 0 with fx plus h minus f at x all over h, and then you're gonna get something that is gonna be what? It's gonna be like this. Yeah, okay. Let me just create some space here for us to write, because these are the following examples. So we'd say fx plus and then limits. It's gonna be limits h is to 0 with f at x plus h. F at x plus h you already find the formula yakhona ukuthi laphayana it was gonna be 1 minus 3x squared. This was the answer we got for fx plus h. 1 minus 3x squared minus 6xh minus 3h squared minus. So now we're minusing what? We're minusing, let me just put something that is gonna be bright. Yeah, we are minusing what? We are minusing the f at x. The f at x was 1 minus 3x squared all over h. So the limits h is to 0. So yeah, 1 minus 3x squared minus 6xh minus 3h squared minus 1 plus 3x squared. So now I just multiplied here, so that is why I have a plus 3x squared over h, and then limits h is to 0. So what is going to be cancelling each other here? In this case, the things that are going to be cancelling each other, it's going to be the 1 and the 1 minus 1, and the 3x squared and the 3x squared are going to be cancelling each other. And then after that, you're going to be getting something that is going to be saying negative 6h minus 3h squared all over h. Now, what did I say? If you have two factors on top, just try to factorize. So here, when you're factorizing, we do have common factors of h. Yeah, well, so we can just take out the common factor of h. I know there's a 3 too that you can take out, but you will see why there's no need to take out the 3. So just take out the h only, and then you're gonna be left with negative 6x minus 3, and then you're gonna be left with 1h on the 3, and then all over h, and then these will cancel each other. But we are still left with, because now the limit h is to 0 will still be there, but y is still there because there's still an h present, you know. So because of that, what are you gonna do now? Here, that is whereby you're gonna be using the 0 in this next step. So now negative 6x minus 3, and then I'm gonna put the 0. Did you notice whenever I start to put the 0, I no longer write the limits is to h is to 0, because now I've used the 0, you see. And then now the answer is gonna be what? Negative 6x. So this is my limits. It can have an x, yes, it can have an x. It does not mean it must be like a one value, you see. So and don't forget to write f prime x, the average gradient, negative 6x. So yeah, this is the formula for the gradient. Yeah, boy. So let's move on. This is the first principle. Yeah, boy. It's so easy. Determine the fx plus a. So here also, so they said that you must find, I forgot to put the cap from first principle, if f at x is, so the same thing we're doing, determine the fx plus h. So negative 3 and then x plus h all cubed. In this one, it's gonna be tough, but I know that there's gonna be x plus h, x plus h, x plus h. So yeah, 3 brackets, and then I know one of the brackets would be x squared plus 2x plus h squared is 2x plus h. Yeah, and then take the x, will be multiplying step by step. So you're gonna get x cubed plus 2x squared h plus xh squared. That is for the x, ne? And then for the h2, so for also the h, what are you gonna be doing there? Because it was plus, about plus h, the h is gonna be it's gonna be multiplying there, so it's gonna be x squared h plus 2x. So let me just show you by arrows. So here's the h, and it's now h, and now we are multiplying. Yeah, so it's gonna be 2x h squared, because it's the h multiplying to the 2xh, and it's going to be h cubed at the end because it's going to be h squared times h. So yeah, negative 3, and then is there, okay, inside the brackets, are there any like terms? Because now there are many x's in h, so let's go find some like terms. Here there's x squared and h, x squared and h also here, so that gives us, currently we have something that is gonna say x cubed plus 3x squared h, and then also we have in 40 we have xh squared and then xh squared, so that means we also have 3xh squared plus h cubed. So now we can multiply this negative 3 inside the brackets above. So it's going to be negative 3x cubed minus 3 times 3, that's going to be 9, right? It's going to be 9x squared h minus 9xh squared minus 3h cubed. So this is going to be your fx plus h, yabo. So when you are doing your formula for, it's going to be f prime x equals to the limits h is to 0 with fx plus h minus fx all over h. So it will give you what? Limits h is to 0, go and put in your formula that you just did, negative 3x cubed minus 9x minus 9x squared h minus 9x h squared minus 3h cubed, minus brackets, remember the formula, which is going to be minus 3x cubed, so minus 3x cubed all over h with the limits h is to 0, negative 3x cubed minus 9x squared h minus 9xh squared minus 3h cubed plus, because the negative and the negative, so plus 3x cubed all over h. After that, you're gonna see it's so easy after in here, because now they'll be cancelling each other, and then you left with what? You left with negative 9x squared h minus 9xh squared minus 3h cubed. What are you gonna do in this case? The thing that you're gonna do is take out the h. I know that you can do a lot, but take out the h. So take out the h, and then you're gonna be negative 9x squared minus 9xh minus 3 with h squared all over h. So in this case, you are left with negative 9x squared minus 9xh minus 3h squared. Now I'm gonna be, okay, these are gonna cancel each other. Now I'm gonna use the h of 0. So now where there's h, I'm gonna put 0, not where there's x. Where there's h, I'm gonna put 0. So 9x is 0 here, 0 here. So yeah, these are gone, and then you're only left with the answer negative 9x squared. So this is gonna be your answer for your f. Yeah, so I'm gonna be sending the classwork to you, and yeah, I'm gonna do the classwork and then send it back to me so I can provide the answers. Thank you. For any questions, yeah, use email.